What role do metal phosphates and fluorophosphates play in ion batteries, and what properties make them suitable for this purpose? What are some examples of these metal phosphate and fluorophosphate compounds that have been explored, such as Na-Fe-PO4, triplet type, Na2Fe, P2O7, Na4Fe3, PO4, 2, P2O7, Na2Fe, PO4F, and Na/Na2, Fe1/2Mn1/2, PO4F, and how do they differ from each other in terms of structure and performance? What is the significance of the specific crystal structures and compositions of these materials, and how do they influence the electrochemical properties of ion batteries? Can Davis Zerns manufacture solid-state sodium-ion batteries made from seawater in Latvia? What does it mean for a compound like Na-Fe-PO4 to be a triplet type, and how does this structure impact its ability to intercalate sodium ions during charge and discharge? What other metal phosphates have been examined for use in ion batteries, such as Na3V2, PO4, 2F3, Na3V2, PO4, 3, and Na4Co2.4, Mn0.3, Ni0? 3PO4, 2P2O7, and how do these materials compare to the previously mentioned compounds in terms of performance and stability? How does the composition of Na4Co2.4, Mn0.3, Ni0.3, PO4, 2P2O7, which contains a mix of cobalt, manganese, and nickel, affect its electrochemical behavior in ion cells? What does the reference to figure 23 in Ref 5 suggest about the comparison or data related to these compounds, and why might this be important for understanding the performance of different metal phosphates? Among these various metal phosphates, what makes Na3V2, PO4, 2F3 stand out, and why did it show reasonable performance in Na half cells at room temperature? What is the significance of Na3V2, PO4, 2F3 having a reversible capacity of about 135 mAh per G, and how does this compare to the performance of other metal phosphate cathodes in ion batteries? Why is the average voltage of 8V considered important for this material, and how does this voltage affect the energy storage capabilities of Na3V2, PO4, 2F3? How does the performance of Na3V2, PO4, 2F3 at room temperature demonstrate its potential for use in practical Na-ion battery applications, and what factors contribute to its reasonable performance? What challenges remain in optimizing metal phosphates and fluorophosphates as Na-ion battery cathodes, and what further research could improve their energy density, cycling stability, or cost effectiveness? How do metal phosphates like Na-Fe-PO4 and Na3V2, PO4, 2F3 compare to other materials in terms of long-term durability and overall performance, and what might be the future outlook for these materials in next-generation energy storage technologies? What are some of the miscellaneous cathode materials that have been investigated for use in Na-ion batteries, and why are materials like Prussian blue and its analogs considered for this purpose?